In this video, we're going to look at some basic graph transformations. We're going to look at three particular types of transformations and the effect that they will have on a graph. In an exam question, you'll often be given a graph and it will be labelled the f of x. The first transformation we're going to look at is a translation. A translation simply picks the graph up and moves it. Lower down school, you might have done translations with shapes. Exactly the same thing happens with a graph. The first type, we have the f of x plus a. This moves it up or down. If this value of a is positive, it moves up. If it's negative, it moves down. So the f of x plus 5 moves it up by 5 units. The f of x minus 2 moves it down by 2 units. The next type is the f of x minus a. This moves it left or right. If we have the f of x minus 5, it moves right by 5 units. If we have the f of x plus 3, it moves left by 3 units. That might seem counterintuitive, but as we go on with our work, we'll appreciate how and why that happens. So, if it's on the outside, it's going to be changing the y coordinates. If it's on the inside, it's going to be changing the x coordinates. And that's true for all of our transformations. So if it's on the outside, i.e. the a is on the outside, we're changing the y. If it's on the inside, we're changing the x. So let's grab up a graph. And what I've got now, let's put this one on. This is just y is equal to the f of x, and this one in particular is x squared. So a nice straightforward graph that you'll recognise. 1 squared is 1, 2 squared is 4, and so on and so forth. So this is just the f of x, and we call this the f of x. This one now is the f of x plus 1. I've just moved this up by 1 unit. So if we were given this one now is the f of x plus 1 unit. So we've moved it up by 1 unit. If we look at the f of x minus 2, we've moved this down by 2 units. So we've gone from 0, 0 to 0 minus 2. And all these points are being moved down. So we can see this point was 2, 4, it's now 2, 2. This one I've just done is the f of x minus 2. So these are now vertical translations. I've just picked it up and moved it up or down. If we now look, and we'll take these two off, we're going to look at some horizontal translations. This one right here is the f of x minus 1. So we've got x minus 1 in the brackets, and we can see this has moved 1 space or 1 unit or 1 to the right. So this particular one now is going to be the f of x minus 1. If we look at another particular type, another horizontal translation, this has moved left by 3. So this one right here will be the f of x plus 3. So these are both horizontal translations. So let's have a look at that one. We've gone from 0, 0 to minus 3, 0. This point you can see has gone from 1, 1 to minus 2, 1. So all we're doing is picking this up and moving it left or right. Okay, let's get rid of those. The second type we're going to look at are stretches, and these are ones that often cause people most hassle. The first one we're going to do, let's just write this up now, stretches. So stretch is, the first one we're going to look at is a f of x. This is a scale factor stretch of a in the y direction. The next one we're going to look at is the f of ax, and this is a scale factor stretch of 1 over a in the x direction. So if it's on the inside, it's affecting the x coordinates. If it's on the outside, it's affecting the y coordinates. So let's start with this one right here. If I had 2 f of x, all we're doing is multiplying the y coordinates by 2. Or whenever we got our function, whatever value is, we're multiplying it by 2. So if we look now, this point right here is going to be 1, 1. This is x squared. If I do now, the one that I've just written, 2f of x, we can see instead of 1, 1, it's gone to 1, 2. I'm simply doubling the y coordinates. If we pick another point, let's pick another point. This point has gone from 2, 4 to 2, 8. So you can see that we're multiplying now, let's get that back there, we're multiplying the y coordinates by 2. So this one that I've just drawn is 2f of x. It's on the outside, so it's going to be changing the y coordinates. The next one that I'll do is going to be 3f of x. So this time what we'll see is that the y coordinates are going to be trebled. So if we put that one on, what we've got here, this point from 1, 1 has gone to 1, 3. If we now look up here, what we're going to have is this point right here, and it's gone from 2, 4 to 2, 12. So that's a scale factor stretch of 3 in the y direction, or in general, the scale factor stretch of a. So these are stretching it upwards, and if you had a half, you would just half the y coordinates. So 1/2 f of x, instead of it being at 2, 4, it would be at 2, 2. Okay, let's look at the other ones now, and what we'll look at is the f of 2x. Now the f of 2x, we're not multiplying the x coordinates by 2, we're dividing them by 2. So let's grab that one up now, so we'll get rid of these ones. So this time, this one is going to be the f of 2x. We can see that the y coordinates have halved. The x coordinates have halved. Best point to start, 2, 4 has gone to 1, 4. So we're halving the x coordinates. This point right here has gone from 1, 1 to 1/2, 1. If we pick another point up here, let's grab another point. Okay, so what we've got now is 3, and we've got 3, 9 has now gone to 3/2, or 1.5. So on that one, what we've got is the f of 2x, we're halving the x coordinates. F of 3x, we're dividing the x coordinates by 3. So this is going to be even closer in. So that one will look something like so. So if you want to pick a point, you will see that these are going to be divided by 3. So this point now, this was the original, was at 3, 9. It's now at 1, 9, as we're dividing the x coordinates by 3. Okay, if we think about the next one, and we'll do this one, if we do f of 1/2 x, we are dividing the x coordinates by 1/2, which is the same as multiplying by 2. So if I do that, what we're going to end up with is the following. So we've gone now, and we've gone from the point, remember, we're doubling up the x coordinates. So we've gone from this point 1, 1 to 2, 1. We've gone from 2, 4 to 4, 4. So that particular example now is the f of 1/2 x. Okay, let's get rid of those ones. The next ones are fairly straightforward. These are reflections. So let's do reflections. Okay, and put that just there. Let's underline that. Look neater. So the next one are reflections. We have two types of reflections. We have minus f of x, and we have f of minus x. This is reflecting in the x-axis, and this is reflecting in the y-axis. So if we have minus f of x, remember it's on the outside. This minus 1 is on the outside, so we're going to be changing the y coordinates. Another way of looking at this now is that we're just simply going to multiply all of the y coordinates by minus 1. On this one, we're multiplying all the x coordinates by minus 1, which means it's going to reflect in the y-axis. You might be one step ahead and appreciate, because we're using now x squared, that's going to be symmetric. It's fairly straightforward. If that point now is going to be reflected, it's going to look exactly the same. That won't always be the case. It's just in this particular case it's going to be. Okay, let's now do the... So this one now is the following. Let's put that one there. That's this one right here, minus f of x, and that's reflected in the x-axis. So this point 1, 1 is now 1 minus 1. So we're multiplying the y coordinates by minus 1. If you are doing a graph transformation, generally you'll be expected to show a sketch, but you will need to put key points of information on. So as we go through the video, I'll show you the kind of things that you're going to need to put on to show your transformation. You're not going to be plotting these, you're just simply going to be sketching and putting some key features on. Okay, let's just look at now the f of minus x. As you can see, it's already on there. It's just the other one that is sitting on top of it anyway. So if I take that away, that's exactly the same as it was as I put the other original one back on there. So there we go. They are now reflections. So we've got three different types: translations, move it left or right, up or down; stretches, stretch it either in the x or y direction; and reflections, just flip it in one of the axes. So let's work through a few and we'll see how we go. So what we've got on this one now, let's put this up here. We've got now the f of x. So here's the f of x, and what we need to do is the f of x plus 1. This is on the outside, so we're simply going to pick it up and move it up by 1 unit. So if I now go from 0, 0, on my sketch, what I'll put here is 0, 1 to show that I've moved this up by 1 unit. That's going to go to there. This point is going to go to here. So all I'm doing is picking this up. We know this one is symmetric, so I'm just picking the points up and moving it up. This becomes a sketch, and it really will be, for me, a sketch on the tablet, because it's an absolute nightmare to try and draw curves on here. So what we'll end up doing is simply picking that graph up and moving it up by 1 unit. If your graph is absolutely useless, you might want to say to the examiner that you're translating it. And the vector translation we're going to do is going to be 0, 1. We're moving this up by 1 unit. But the fact that I put 0, 1 on there will inform the examiner that I know what I'm doing. Okay, let's look at another one. This one now is the f of x minus 2. So in this particular one, we're going to simply move this to the right by 2 units. Remember, if that's a minus, we're moving right by 2 units. So 0, 0, we're now going out to be 2, 0. And I put that on my diagram. All we've done is picked up all the points, and we're simply moving them right by 2 units. So if you pick another point, and you can pick that and put it just there, that point is going to go there. Exactly the same shape. With a translation, there is no alteration in the shape. All we've done is picked it up and moved it across the axes. These graphs will want to be as neat as possible, and as you can see, mine are certainly not fantastic, but all we've done is picked it up and moved it. So that's the f of x minus 2. Okay, next one, what we want is 2f of x. So we're going to be multiplying the y coordinates by 2. So this point is at 1, 1, it now needs to go to 1, 2. This point is at 2, 4, it now needs to go to 2, 8. I keep my x coordinates exactly the same, but multiply my y coordinates by 2. This is a scale factor stretch of 2 in the y direction. So this point remains 0, 0. As if I multiply 0 by 2, it's still going to be 0. And then we just sketch this up, and we show that this is going to be a scale factor stretch of 2 in the y direction. So we're stretching, and that should have really gone through that point, and it will look something like that. So scale factor stretch in the y of 2. Okay, let's do another one. Minus f of x. So this now is the reflection in the x-axis. So this point 1, 1 is going to go to 1, minus 1. This point 2, 4 will go to 2, minus 4. Another way of looking at this, we're multiplying the y coordinates by minus 1. This point will be here, we'll still be at the origin, and then we'll have this point right here. So it's simply going to be a reflection in the x-axis. It will look exactly the same in terms of its shape, it will just be flipped over. And there we go. So this now is minus f of x. If it had been f of minus x, it would be reflected in the y-axis. Okay, f of 2x. So this time we need to halve the x coordinates. If we got f of 2x, we halve the x coordinates. If we got f of 3x, we divide the x coordinates by 3. If we've got f of 1/4 x, we multiply the x coordinates by 4. So this point right here, we're just going to move them in. So this point is going to go from 1, 1, and what we're going to do is have 1/2, 1. It's often easier to pick the nice numbers. So this point has gone from 2, 4, and that will go to 1, 4. And then this point right here, which is going to be 3, 9, will go to 3 over 2, or 1.5, 9. So all we've done now is divided the x coordinates by 2. This will look very similar now to the stretch upwards that we had. And that is a key thing to consider. Of course, this point is going to stay 0, 0, but what we're showing now is that this is going to be a scale factor stretch of 2, or 1 over 2, I should say, in the x direction. So that's what we end up with, f of 2x. Okay, f of minus x. This is the one that is going to look exactly the same. So this point is going to go over to here, that point's going to go over to there, that one will go to here, this one will go there, and we will have exactly the same. And it just shows I can't even trace on the thing, and I'm really paying attention to making that look neat. Okay, and all it will do is be a reflection in the y. So it's reflect in y-axis. With other graphs, we'll see later that this is going to have a better effect, but f of minus x reflects in y. Okay, f of 1/2 x. So this time we're dividing the x coordinates by half, which is multiplying by 2. So we're going to go from 1, 1, and then we'll have 2, 1. This point right here is going to be 2, 4. This is going to go out now to 4, 4. So what we'll see is that this graph is going to be more open. It's going to open up and be less tight to the y-axis. So what we'll have is this point right here. And it looks something give or take like so. And remember, again, it's going to go through the origin, because if we divide or multiply the x-coordinates when x is 0, it's going to be 0. So it looks something like so. So now f of 1/2 x. Okay, this one right here, all we're doing is a translation. We'll move it 1 to the left, and then we'll move it 2 down. So if we pick some points, it'll be nice and straightforward. All this is 2 translations, one horizontal, one vertical. So this one is going to move 1 to the left and 2 down. So from the origin, we're going to move 1 to the left and 2 down. This point, 1 to the left and 2 down, which will be just there. If you want to pick another point, 1 to the left and 2 down. If you want to pick another point, let's pick this one, 1 to the left and 2 down. Pick another point, 1 to the left and 2 down. And this is just simply a translation. And all we're going to do is move this. Okay, and what I'll do on here is place this point, and I'm just going to put some information, and again that's kind of looking a bit sketchy. This point now is going to be 0, -1. So what I've done, I've moved this left by 1 and then down by 2. Okay, so that's what we end up with. You might want to put the minimum point here as well, and this minimum point is going to be -1, -2. You'll be told exactly what information you need. You might be asked for the minimum point of a graph. You might be asked to show where it cuts a certain axis, the x or y axis, but you need to label that information if you're asked for it. Okay, so there we go. That's the effect that the transformations can have on x squared. What we'll now do is look at a generic graph. I have called this one f of x2. I should really call it the g of x, as it's something different, but hopefully you'll see some of the transformations we can perform on this. So this one, the f of x plus 3, this is a horizontal translation of 3 units to the left. So this point is going to be moved 3, this point right here will be moved by 3, and this point right here will be moved by 3. So what we'll end up with is exactly the same shape, but all that will happen, it's being moved to the left by 3 units. And it'll look something like so. So at this point, if you asked on your graph to label the information, this point right here would be -1, 0. If you were asked for this point right here, this point would now be 0, 2. Okay? All depends on what the question asks. Generally, we'd be expected, in this case, to put -1, 0. Okay, let's look at another one. 2f of x. So on this one, we need to multiply the y coordinates by 2. So this is 4, 4. So we're going to go out to 4, 8. This point now is -4, 2. So we need to do -4, 4. Remember, this is stretching the y coordinates by 2. So multiplying the y coordinates by 2, and we would put this on, and we'd label it up now 2f of x. Again, if you want to put on this point right here, depending on what the question asks for, this point now is going to be 2, 0. You might be asked for this point right here, and we can see that this is going to be 4, 8. It was at 4, 4. This point right here was at -4, 2, and now we're at -4, 4. It's highly unlikely you'll be asked for all of that information, but hopefully that shows you all we've done is multiplied the y coordinates by 2. Okay, another one, the f of -x. Now this is a reflection in the y-axis. We saw on the last video that it was pretty pointless doing it with x squared. This time it'll be more interesting. So another way of looking at this, you're going to multiply the x coordinates by -1. So this point's going to go over here. This one is going to go now from -4 to +4, which is going to be just here. This point is going to go from here to here, and we're simply going to reflect it like so. So if we do that, what we'll have is exactly the same shape just now. So there's no stretch on it. It will just be symmetric. So there we go. And again, depending on what particular information they ask for, -2, 0 would be a good point to put on there. Okay, let's look at this one, the f of x minus 3. So this is a horizontal translation. All we need to do is move this by 3 units to the right. So that point's going to go from 2, 0 to 5, 0. That point's going to go from 4, 4 to 7, 4. This point is going to go from -4, 2 to -1, 2. Just move that now. And all we need to do is a quick sketch of that. So let's move that across. And that will do something like so. and then that will go something like so. So exactly the same shape, it's just a horizontal translation of 3 units to the right. So 5, 0 will place on here. Okay, f, so minus f of x, so this is being reflected in the x-axis. Remember, it's on the outside, the y coordinates are going to change. So this point will remain the same. We often term this as invariant. Invariant means it's not going to move. This point has gone from 4, 4, so we're technically multiplying the y coordinates by -1. So this point is going to go from 4, 4 to 4 minus 4. This point is going from -4, 2 to -4, -2. So let's now just sketch it up. And what we'll have is a reflection in the x-axis. And it looks something like so. So there we go on that one. Okay, the f of x plus 2. What we need to do with this one is move it up by 2 units. So if we consider this point right here, move it up 1, move it up 2. If we consider this point right here, move it up by 2. And then this one right here, we'll move it up by 2. So what we'll now get is the following. And we'll place this on like so. That will be there, and that will be just here. And generally in an exam, you'll be asked for the minimum point. And the minimum point now, it was at 2, 0. It's now at 2, 2. So this point was 2, 0. But because we've moved it up by 2 units, it's now 2, 2. Okay, so there we go. Basic graph transformations. You might be asked to do some combinations, but essentially that should get you rolling on what you need.